Hello, welcome to Fact Fluency Uncomplicated. I'm Susan with the Math Spot, and we're here to talk about how your students acquire and memorize their math facts. So today we'll start with fluency and the standards. If we look at the Common Core standards, it shows us which facts our students are needing to learn from memory and which facts students need to be able to solve fluently at a variety of grade levels. We'll then jump into the three levels or the three layers of fact fluency instruction. We'll talk about fact relationships, leveled strategies, and levels of support. Finally, we'll talk about assessment and the next steps you'll take with your students. Before we get started, I'm Susan. I'm a former and future math interventionist with over 10 years of experience teaching students in levels kindergarten through fifth grade. I began as a special education teacher and then transitioned into math intervention. When my kids were born, I stepped away from the classroom for a few years, but I do intend to go back because I absolutely love teaching and know that's where I want to end up again. Let's take a look at fact fluency in the standards. Fact fluency is baked into the Common Core standards. When we look at the first grade standards, we notice that students are adding and subtracting within 20 and are only demonstrating fluency for addition and subtraction within 10. Now, we'll talk about a little bit later on what it means to demonstrate fluency and the levels of fact solving strategies. But it's important to note that in first grade, our students are only demonstrating fluency for facts within 10, and we're not asking our students to know any facts from memory at this point in time. When we look at second grade, students are now fluently adding, subtracting within 20 using mental strategies. And by the end of grade 2, students need to know from memory all sums of two one-digit numbers. Now, you might be thinking to yourself, isn't that the same thing, adding within 20 and the sums of all two one-digit numbers, right? 9 plus 9 is 18, so we're pretty much at 20 anyways. The difference here is that the facts your students need to know from memory are those single digit facts: 1 plus 5, 7 plus 6, 9 plus 3. Fluently, your students need to fluently add and subtract within 20. So this doesn't necessarily need to be those one digit number facts. So your students would need to fluently be able to add 17 plus 3. That's a fact that's within 20 that isn't a sum of two one digit numbers. Additionally, you'll notice that from memory, your students need to know all sums of two one-digit numbers. So we're asking our students to have their addition facts from memory for numbers up to 20, the one-digit numbers. But subtraction is not yet from memory. In third grade, students need to fluently multiply and divide within 100. And by the end of third grade, they need to know from memory all products of two one-digit numbers. So in third grade, your students are beginning with those strategies to multiply and divide within 100. But by the end of the year, they also need to know those facts from memory. Again, there's a little bit of a caveat here with memory is for the products of one-digit numbers. Whereas fluently, we might be able to expect students to multiply, for example, 2 times 30, right? A number with where you're multiplying by a decades number. Now, depending on which state you're in, some states or others expect third grade to multiply by a decade number, but for the purpose of our discussion here, that's neither here nor there. We need to know that at the beginning of the year, students are learning strategies to fluently multiply and divide within 100. And by the end of the year, they need to know all products of two one-digit numbers, so all their multiplication facts from memory. So what is the goal of this fact fluency instruction? Based on the standards, we can see that fact fluency means students are solving accurately, quickly, and flexibly. Additionally, in the standards, we notice that there are certain facts at certain grade levels that students do need to access immediately from memory. Now that we have that out of the way, let's look at what the heart of our fact fluency instruction will look like. So for me, I see three different bodies of research or work that really support fact fluency in our students. The first area we're going to look at is fact relationships. Next, we're going to talk about within each of those fact relationships, what strategies can our students use to add, subtract, multiply, and divide. And there are 3 very clear leveled strategies that we'll find there. Finally, we're going to look at the levels of support we can provide to students while they are learning these facts. And that's kind of what can we do as teachers to support our students in understanding these fact relationships at a variety of levels using different leveled strategies. So let's dive into what this looks like. When we're talking about fact relationships, memorizing over 100 individual addition facts and over 100 individual subtraction facts and over 100 individual multiplication facts and over 100 individual division facts is an unrealistic task that we are setting forth for our students, right? If you think to yourself, I'm just going to start with the 0 facts, and then I'll test my students on those. When they're good at them, we'll move on to the +1 facts. When they're good at those, we'll move on to +2. And I'm going to do this with flashcards and games. So my students are just going to practice, and they're going to memorize these facts. You can see that in the beginning, that might work. But by the time we put together addition, subtraction, multiplication, and division, this is an unrealistic task to ask your students to memorize over 400 individual facts. So, what can we do instead? Instead, we're going to help our students to recognize and understand how to deal with a variety of fact relationships. So, for example, if you look kind of at the chart I have here, if we talk to our students about what does it mean to add 0 to a number and have an understanding of adding 0, we can then wipe out 20 of our facts right there, the +0 facts and the 0 plus facts. Now, just because your student recognizes 3, if I have 3 cookies and someone gives me no more cookies, of course I still have 3 cookies. They might understand that fact relationship, but what you're going to have to work to do is make the explicit connection between that relationship and those facts for your students. Your student will not necessarily recognize that 3 cookies and no more cookies is the same as 3 plus 0 equals 3. So when you're working with these fact relationships, you really have 2 tasks here. The first task is to help your students to understand that relationship and be comfortable with that relationship. Your second task is to make explicit the connection between that relationship and that math fact. And we'll talk more about that when we talk about our levels of support. Another fact relationship when you are talking about addition subtraction is 1 more and 1 less. And you can see on the chart, kind of written in pink there, is highlighting all the 1 more, 1 less facts. Now, if I can take a side quest for a second and talk about number sense in our students, number sense being able to work flexibly, efficiently, accurately with numbers, flexibly with numbers. This is one of those main number sense relationships, 1 more and 1 less. It's about having that internal number line for numbers that your students can kind of see. If I have 7, of course, 1 more is 8. Again, you have the task of making your students not only understand that relationship, but making the explicit connection to what the equation looks like and what that equation is that matches that relationship. On the same token, 2 more and 2 less is another one of those number relationships having to do with your students' number sense. So your students might have the internal number line to say, okay, if I know 3, 2 more, so skipping 1 number over on the number line is 5. Again, and I'm going to sound like I'm beating a dead horse here, but it's really that important. It's your job to make the explicit connection between that relationship that your students know and feel comfortable with and the written equation. Another fact relationship is the doubles facts. Doubles facts come naturally, easily to students. And once your students know their doubles facts, they can use that information to then work on facts like doubles +1 and doubles -1. Now, again, we're going to get into those layers of math instruction later, or those layers of fact strategies, and we will speak more to this point. The next relationship, or the last relationship, is partners of 10 and partners of 10 plus and minus 1. We know it's really important for our students to know their partners of 10. The Common Core Standards calls this out. Many state standards call this out. But if your students know their partners of 10, if they know 6 plus 4 is 10, then they can use that information to solve what's 7 plus 4. And again, we're not asking our students to memorize over 100 individual addition facts. Instead, we're just saying, let's work on the numbers that make 10. And if we know those numbers that make 10, what can we then also know by adding or subtracting one using nearby facts? And then, I'm sorry, there was one more relationship. The make a 10 facts. The facts for numbers that are greater than 10, where you can kind of break apart one addend to make a 10, and then think about the number relationship with teen numbers. So for example, 9 plus 4 is really similar to, or it's the same as, 10 plus 3. We can break apart that 4, put 1 together with the 9 to make 10, and then have 3 more left over to make 13 total. So instead of learning over 100 individual addition facts, what we're really asking your students to do here is learn these 1, 2, 3, 4, 5, 6, 7 fact relationships, and to work deeply with these fact relationships. And when they understand those fact relationships, they then know those over 100 individual addition facts. There are very, very few facts that don't fall into one of these 7 relationships. Now, when we go on to subtraction, we don't need to teach a whole new set of fact relationships. Instead, we're going to help our students to see the connection between addition and subtraction. We're going to work with fact families, because think addition is an incredibly powerful way for students to think about subtraction. So doing fact families work, doing missing addends work, and then being explicit about how those relationships match the subtraction equation can help your students learn those over 100 subtraction facts just by relating it to something they already know. I've said it before, and I'm going to say it again. You need to be explicit. Just because your students know that 2 more than 5 is 7 does not mean that they will recognize 5 plus 2 as being representative of that relationship. So as you're working through these fact relationships with your students, you're constantly going to be both supporting the relationship and pairing those relationships with the written equation so that students are making that connection. Next, we're going to go into the leveled strategies for solving math facts. So we have our level 1, that's our count all strategies, our level 2, which are our counting strategies, and then level 3 are related fact strategies. At level 1, the count all strategies, this is when a student needs to count both addends and then count them again together to find the total. So you see the student here showing 2 fingers, showing 5 fingers. To solve this problem, they would show 2 and count 1, 2, show 5 and count 1, 2, 3, 4, 5, and then say, I know addition puts things together. And now they're going to count all of those fingers again, 1, 2, 3, 4, 5, 6, 7, to find their total. This is count all strategies. So you can use count all strategies using blocks, using counting bears, using fingers, counting dot pictures, whatever it is your students are putting together. You'll know you're at a level 1 strategy if your students are counting every single item in order to put them together. Level 2 takes this a step further. This is when your students have some conservation of number. They have some trust in their numbers. So for example, here, if I told my students I have 5 blocks underneath the cup and 3 more blocks outside of the cup, how many blocks do I have altogether? Students who could use a level 2 counting strategy would be able to tap the cup and say 5 and then count on from that number. So 5, 6, 7, 8. 8 blocks total. This is a level 2 strategy. So a level 2 strategy might look like this. It might look like using a cup and blocks. It might look like students using their fingers and saying, I have 5, and kind of grabbing that number into their fist and then counting on 3 more fingers to find a total of 8. This might look like a student pointing to the number 5 and then pointing to 3 more dots as they count on 6, 7, 8. That's your level 2 counting strategies. At level 3, your students are able to use related fact strategies. This is so much more difficult because now your students aren't just holding on to a number that they know. So for example, in that last slide we looked at, your students were holding on to the 5 that was under the cup and then counting on 3 more. Here, your students are holding on to an entire fact that they know and feel confident with, and then are also manipulating the numbers in the equation to solve a fact. So for example, when we talked about our number relationships earlier on, when we talked about doubles and doubles plus 1, that's a related fact strategy. So if students are solving 5 plus 6 by thinking, oh, that's the same as 5 plus 5 and 1 more. Okay, that's a level 3 strategy. It's an extremely efficient way to think about numbers. If you do mental math as an adult and you don't know a fact from memory, this is likely how you're solving facts. You're using related fact strategies. And this is where we want our students to work towards, but it is absolutely not where students begin. And in so many math programs, you see students spending time working on learning these level 3 strategies when they're still not understanding addition or subtraction at the level 1 or level 2 level yet at this point in time. So you want to be really clear about what level your student is working at and where they are understanding and trusting numbers and understanding and trusting equations, so you can be working from the spot that is most appropriate for each of your students. So we have one more layer of fact fluency left to add on. It's those levels of support, but let's take the first 2 layers of fact fluency so far and see how they might work together. So for example, if I'm working on the fact relationship of 2 more, and I have a student who is working at the count all level, that might look like showing your students 5 plus 2, and they're putting out 5 blocks, and they're putting out 2 blocks, and they're counting them all together. That's what that would look like there. Now, you have students who are starting to feel a little bit more confident. They're really successful with that. So now you're going to stay in that same fact relationship. You're still going to be working on 2 more. And now we're going to say, let's think about counting on. Can I start at 5 and count on 2 more? And then finally, once your students are comfortable there, we're going to talk about related facts. So the related facts, it's also number relationships that your students are comfortable with. So if your students have the number sense to say, I know 5, I can think about the number line, 2 more is 7. They're going to be comfortable saying 5 plus 2 equals 7. You're making explicit that connection between what number relationship do I know and what math facts match that relationship. Let's add on our last layer of our fact fluency formula here, and this is the layers of support. So the layers of support that you can lend in your classroom in terms of materials, manipulatives, diagrams, here's what you can provide. You can provide support at the concrete level. This is hands-on materials like blocks, fingers, figurines like counting bears. You can have layers of support at the representational level. This might be drawings or diagrams. This is your part whole drawing. Depending on your program, some programs call it a math mountain. That's your representational support. And then finally, at the abstract level, that's where you just have numbers, thoughts, words, just equations by themselves. So I'm going to take the math out of the equation for a second here and just talk about these layers of support. If you're talking to someone who has never encountered an apple before, right? If you're trying to convey an apple to an alien, the most effective way to help them understand what an apple is to give them a physical apple. a real apple. Let them touch it, let them taste it, let them smell it, let them experience the apple. That's a concrete level of support. Moving to a less supportive layer would be showing someone a drawing, right? So if you've never heard of an apple before, I can show you a picture of an apple, maybe a diagram of an apple, and then you can see, oh, I kind of see what it looks like. I can understand the different parts. I have an understanding that the outside has a skin on it and the inside has a different colored flesh and some seeds. You can gain an understanding of an apple from a picture. Now, it's not going to be as robust as if I gave you an apple and let you crunch into it, but it's going to be supportive. And for someone who has experienced an apple before, but maybe only once or twice, showing them that representational model, just that picture, might be enough to jog their memory and say, oh yeah, I know what I'm talking about. That's enough support. I can move forward with a full understanding. The final layer of support is that abstract level. If you say to someone who has never encountered or experienced an apple before, I had an apple for lunch today, they might be able to infer that an apple is food, but that's about as far as that understanding goes. Now, if you have someone who has experienced an apple, you gave it to them, they touched it, they tasted it, they smelled it, and then another day you showed them a picture of an apple and they said, oh yeah, I remember the apple. I experienced that. This picture is helping me to understand and remember that. And now here on the third day, I say to them, I had an apple for lunch today. They're going to know and understand what I ate for lunch. Oh yeah, it was that red fruit with the red skin and the crunchy and it was sweet inside and juicy. So by providing layers of support for your students and starting concrete, moving to representational, and then ending with abstract, you're going to help your students gain a more full and complete understanding of the topic. So we can apply this to math as well. If we're looking at solving 2 plus 3 and we're at the count all level, concrete materials might look like using blocks. And you're showing, I have 2 blocks, I have 3 blocks, and adding puts things together. So let's count all of these blocks together. And your students can then take those blocks and physically push them together to see what addition does. Now, slightly less supportive is a drawing. I see 2 circles, I see 3 circles, I can count them and push them together, or I can count them together to find the total. This is less supportive than the blocks because your students can't physically touch them and move them together to show what's happening with the operation of addition, but this drawing might be enough to support your students to being able to solve what is 2 plus 3. Now, the final level of support here is just that plain equation, 2 plus 3, and asking your students, can you solve this? It also might look like word problems. I bought 2 red apples and 3 green apples. How many apples did I buy in all? Both the equation and word problems are at that abstract level. If your students aren't confident with representations, if they're not confident with hands-on supports, they're going to really struggle at the abstract level. But ultimately, this abstract level is where you want your students to be. So although we might offer our students supports in terms of blocks or supports in terms of pictures, we are going to constantly pair the blocks and the pictures with equations. We're going to constantly pair them with word problems so that when we get to the abstract level, our students are feeling confident enough to do that work. So let's look at a couple examples where we put all of this together. So maybe I'm working on the fact relationship of one more, and I'm going to start with the leveled strategy of counting all, and my students are at the concrete level. So we are at the very, very beginning here. So I might say, let's figure out what one more than 3 is. And you might ask your students, can you predict, what do you think? If I have 3 and I add one more, what might that be? And that's starting to get your students thinking at the abstract level, even from the very beginning. And now I'm going to say, I'm going to give you blocks, and I want you to show me, if you have 3, what's one more? Can you use these blocks to figure that out? And your students are going to count out 3, and they're going to count out one more, and they're going to use addition to put those together, and they're going to count all of the pieces. That is what it looks like to work on the one more facts at the count all level using concrete manipulatives. So you worked on that and your students are doing pretty okay. And you say, all right, I wonder if you could do this for me. I want to figure out if I have 5 bears and one more bear comes to play, how many is that? But I'm going to give you a challenge this time. I'm not going to let you use blocks or bears. I want you to draw a picture on your whiteboard that matches my story. So now your students can still use count all. They can still draw 5 circles for the first 5 bears and one more circle for that other bear, and they can count them all together. And you might even ask your students, because you know ultimately you want to get your students to that abstract level. So you might even say to your students, can you write an addition number sentence? Can you write an equation that shows me what it looks like to put together 5 and 1? So we're still working in that one more relationship. We are still working with count all strategies. And at this point, we're giving our students the support of a representational drawing, but we're pairing it with the abstract so that once they take away a level of support, they're still going to be successful in the future. So I want you to notice what's going to happen here. We're going to move from count all to counting on. We're still working on that one more relationship, but now we want our students to trust that first add-end, okay? So if I'm doing 5 plus 1 at this point, I might give them a quick story problem, or I might say to them simply, if I had 6 blocks, and I'm going to put them under a cup here. I have 6 blocks under my cup. How many would I have if I added one more? And now your students are going to tap that cup and say 6 and count one more is 7. And then you're going to open up the cup and say, let's check and see if we're right, because you're going to tie counting all to counting on at this point. And your students are going to count 1, 2, 3, 4, 5, 6, 7. Yes, that works. Counting on strategy, we can trust that the first add-in stays the same. And then you're going to say to your students, could you write an equation that matches 6 and 1 more? Because ultimately we want our students at the abstract level. So we're not going to hold that level back. We're going to start introducing that right from the start so our students can become really, really comfortable. Now, the thing about the levels of support, the concrete, representational, abstract, is that it is not a ladder you're climbing. This doesn't have to be linear. All you're doing here is making connections for your students. The more connections, the more confident they're going to feel in these facts and their understandings. So maybe instead of using blocks, you're going to say, we're going to do one more counting on, and this time we're going to use our fingers to count on. We're going to kind of grab that first number 6 and count on one more 7. Now you might give your students a picture and ask if they can count on. Now in a picture, they're not going to be able to reveal the blocks underneath the cup to count on and count all to be sure that their answer is right. But at this point, your students are starting to trust the strategy. You can move to a representation or a drawing. Again, as you're working, you are always connecting to the abstract, because you're supporting your students with that fact relationship, but you know where you want to go in the end is that abstract level. And so you're going to take your students there all along the way. So we've now talked about which types of facts do your students need to learn and be able to solve with fluency or from memory at a variety of grade levels. And we've talked about the layers of fact fluency, the fact relationships, leveled strategies, and leveled supports that we can use to support our students in becoming fluent. And now we're going to talk about the assessment and the next steps. So the first thing you need to do is regularly assess your students. You need to use an assessment that allows you to notice which fact relationships your students know and feel confident with, and which fact relationships they don't know yet, because that's going to become the basis of your instruction. If you don't already have a program that you're using that allows you to assess your students' fact fluency, I have one. It is free and you are welcome to use it. It's a very, very short assessment, but it has all of those different fact relationships. And then there's a progress monitoring form so you can note the leveled strategies that your students are using and write down the next steps you might have. Now, we know that timed tests can provoke anxiety in students. So you're not going to set your students down for this assessment and say, you have 2 minutes, ready, set, go, try to beat the clock. Instead, you are going to watch the clock as your students work, and you are going to know how long it takes them to complete the assessment. Or You might let your students work for 5 minutes. At the end of 5 minutes, you're just going to say to them, "Great job. You worked hard the whole time. I'm going to let you stop right now. Thank you for showing me what you know." It's not a your students versus the clock issue, but you do want to keep an eye on the clock. You do want to notice whether your students are using level 1, 2, or 3 strategies. And when you keep your eye on the clock, you're going to notice how much more quickly your students are solving the problems on their assessments, and you're going to notice how much more efficient they're becoming over time. Finally, you want to involve your students in the assessment process. Make your students' progress clear to them. Wow, last week you were using count all to solve them. I was noticing you counting all of the numbers on your fingers, but this week there were some problems that I noticed you using counting on, and gosh, you were so much faster and more fluent when you used counting on. Involve your students and help them understand that using these more efficient strategies is helping them to become better mathematicians. I used to have my students graph on a piece of paper how many problems they were able to solve on their assessment correctly. And again, I was not stressing the clock on this situation. I was not stressing the clock to my students, but I was telling them, "Oh my gosh, last week when I watched you show me what you know about math, you were able to solve 5 problems, right? But this week, when you used the counting on strategy, you were able to solve 9 problems. Look at how much more math you can do correctly because you worked so hard on your strategies." Involve your students and help their progress, help them see their progress so that they are also invested in working hard. I have a few related resources that you can find on Teachers Pay Teachers if you'd like some support in this work. So if you happen to teach first grade or students working on the following strategies, I have units on counting on, fact families, missing numbers in an equation, partners to 10, and then the make a 10 strategy for addition. So if you're looking for a 5-day unit that brings you from concrete through representational to abstract, that includes progress monitoring, a pre and post assessment, and independent practice. If you're looking for kind of done for you math work, I have those units for you, and I will leave you a link for those. Similarly, if you teach third grade or have students who are working on multiplying by 0 and 1, multiplying by 2, benchmarks of 5, square numbers, and multiplying by 10, you can see that if you look over at the unit introduction chart, I have a 5-day unit about patterns in multiplication that helps your students learn the vast majority of their multiplication facts just by exploring those fact relationships. And again, of course, that includes pre-assessment, post-assessment, and then the unit works its way through concrete representational and abstract materials. And then finally, and we haven't really touched on this, but if we want our students to move from fluency to from memory, our students need to have repeated access to these facts, and they need to be doing these facts over and over and over and over until 3, 1 more is 4, becomes something that's second nature to your students. They know 3, 1 more, 3 plus 1 is 4, of course. I don't even really have to think about that anymore. I just know it. So I have fact fluency games for you. I have games for addition, subtraction, multiplication, and division. And each of these games uses either a dice, dominoes, a spinner, or a deck of cards. So if you have those 4 materials in place, I have tons and tons and tons and tons of math games for you that you can really just copy and leave in a math center with those 4 materials, and your students will have fact fluency practice really for the entire year. I mean, there's a lot of games involved there. So if you're looking to move your students from fluency to from memory, fluency games, math games where they're accessing their facts over and over and over are a really excellent way to get your students there. So that's what I have for you today. Please always feel free to email me at susan@k5mathspot.com or reach out on Instagram. And then if you're looking for any of these materials, I am the Math Spot on Teachers Pay Teachers. Thank you so much for spending your time with me today.